So today we will be talking about remote management. So remote management is a cross of both system administration and DevOps. All right. It is more into DevOps, all right, because there are some pretty skills you will need, all right, very, very pretty skills. Though this is coming from the perspective of system administration, all right, system administration. So we deem it necessary that we need to do a due diligence, right, in this area. So that's why we need to talk about SSH. All right. Now, remote management is a process of using certain utilities, all right, for managing resources remotely. Let's type. It's a process of using different utilities for managing resources remotely. Great. There are several tools today. There are several utilities today one could use to manage resources remotely. All right. Remember those days we normally use, not up till now, we normally use things like remote desktop, remote RDP, remote desktop, remote desktop protocol, aka RDP. All right. Now we are having SSH. Now, remote RDP is native towards Windows environments, while SSH is native to Unix, Linux environments. All right. So for today's class, we will be talking about what? SSH. All right. Great. Let's bring it down. What then is SSH? Let's check. SSH is secure shell. Secure shell. All right. Secure shell. Secure shell. This utility is used to manage remote resources securely. All right. SSH is very, very secure, and SSH runs on port 22. SSH is a TCP IP, it's a TCP protocol. Protocol. All right, great. There's something I need to add to this lecture of which we AWS CLI. Let me call it AWS CLI to wrap this session up. Okay, great. Now, I want to get started. Remember, whenever we create an EC2 instance, go to the instance, and you go to, I thought I terminated these guys, Ubuntu server. I thought I terminated these guys. Ubuntu server. Or let me power it on. Let me just show something. Whenever you create an EC2 instance and you need to access that EC2 instance, all right? You access it via SSH. Via SSH. All right? Great. Via SSH. Now, the kind of SSH we have, remember when you want to create an EC2 instance, you also create along with it a key pair. A key pair. And at some point, we've talked about key pair. So key pair, automatically, AWS generate two keys for you. One is a public key, and the other is what? A private key. The private key gets downloaded to your base machine, which you download. On here, I have numerous private keys. I have about 3 private keys for 3 different services. All right. And the private key comes with .spam extension. Now, the public key, automatically, the public key gets copied into the EC2 instance. I'm going to show us that public key, the location of the public key. Here's my Ubuntu server. Let me check. Then let's go to connect. If I go to connect, the private key is frankkey.pem. So if I copy this guy, the SSH, I'm using the SSH to connect to this EC2 instance. I've copied it. Come over here. I'm going to paste it. Control V. Now, we need to check where the public key is copied to. The public key on my base machine is copied to, if you can see, there's a folder called .ssh. I did not create this folder, but there's a folder called .ssh. I'll change directory into that folder. I'll list the content. Now, there's a file called authorized keys. In this authorized keys, AWS, according to their own design, they've copied the public key into what? The authorized keys. So that I can authenticate with my private key. Now, here's the idea. Here's the idea. Whenever you need to, this is a remote machine. Let's call it EC2 instance. All right. Now, this is me somewhere, user. Now, this user is somewhere, and this EC2 instance is a cloud instance, and this instance has key pairs. Copy. It has key pairs. All right. The private key is with the user, while the public key is on the EC2 instance. Is on the EC2 instance. Now, before this user can connect to this EC2 instance, this user is going to put his private key online. It's going to connect with his own private key, owning to the fact that he has his public key already resident on this EC2 instance, right? So now, this private key, for this user to connect to this EC2 instance, I'll need 2 keys. One is a private key, and the other is the public key. All right. So you can share your public key with anyone, with any machine. Anybody can have a public key, but do not allow anybody have access to your private key. All right. So this, your public key and your private key, does what we call trust. Remember the explanation of what TLS, SSL, TLS, SSL handshake we did yesterday. All right. Now, this is called trust. It's a back and forth communication. If there is a change in the public key, there won't be any connection. You can't connect from using your private key because it has been tampered. Once this private public key has been tampered, it means that the fingerprint has been altered. So there won't be any authentication. Authentication is going to break because something somewhere has been altered, right? But let's forget about that alteration now. The idea here is we're trying to illustrate on AWS. When you create a key pair, the private key gets downloaded to your base machine, while the public key gets uploaded to your EC2 instance. Now, to see that public key, to see the public key, I'm going to log on to my instance. Then there's a hidden file, there's a hidden directory called .ssh. I will change directory into what? .ssh. Now there's a file called authorized underscore keys. So what I will do, I will view the content of this file. I'll say cat authorized keys. Enter. Now this is the public key. Now somewhere you can see something here. This is the name of the key pair, Frank key. So if I go to AWS, I come to instances. This particular instance, if I check the key pair name, the key pair, can you see Frank key? That's why at the end of it here, it is indicated. So this that you see here is actually how a public key looks like. A public key looks like. Now, if I try to do anything to this file, see, let me try to remove one A. I'm removing one A here. I've removed one A. Now it means that the fingerprint has been tampered with. If I exit, if I try to connect, let's check. I've rendered that system useless. I didn't mean I know I would have. Okay. All right. There's another way I can go into this system. You can see now, because the public key has been tampered with, something has changed from that end. So I'm now having what? A permission denied. I can't come in. So now let's override what I just did. Now to override what I did, what I will do, guys, watch you. We don't start to. I'll come to what? Connect. Then I'll go to what? EC2 instance connect. I'll click on what? Connect. So let me see if I can override that guy. Yes. Now I'm connected to what? To that EC2 instance within AWS. So what I will do, I will go to what? Change directory.ssh. Now I'll see what? The authorized key file. So I will open this file. I'll go and add that A that I deleted. That's the A. Escape, save, and quit. See what I'm doing? Save and quit. I can exit. No voila. I can close this now. So if I come back to my base machine, that's override. I try to connect back now. I will go inside. Perfect. Because the value that was tampered with has been replaced. That's the real content now. So this is just the surface of SSH, but these are smaller tricks. All right. We are getting into the real deal gradually. All right. Now,
sorry, just a quick question.
Yeah, man.
Yeah, so you said the public key is the one that is being uploaded to your EC2 instance, right?
Yes.
And then the private key is the one that is downloaded to your machine, right?
Yes, the machine.
Okay, so that's why you're able to go back into the EC2 instance from
the console.
Yeah, okay.
No, what I did, I was just trying to illustrate that if the public key is tampered with, to lock you out, because trust has been broken. The trust between your private key and your public key has been broken. All right. So the key has been tampered with. It's something like what we call a man in the middle, kind of a man in the middle attack. Man in the middle attack. All right. Where you don't know what's happening in the middle. You know, you don't know. Somebody may have changed a key, trying to redirect you to somewhere else. So for that, SSH has a mechanism, all right, of if the key is not matching to what you have on your private key, all right, because a key exchange has already been established, all right, established. Now they've shared keys, but now at some point, either of the side, the key is not matching either parts, right? What they shared already is not matching somewhere, so that's why we're having that challenge. Okay. Yeah, so that's why I needed to go through the back door, through the console, all right, through the console to override what I did.
Okay. All right. Thank you. I get it.
Okay. All right. Great. Perfect. Now, let's now see SSH in practical. What you just see is by default. All right. So let me go back to my AWS, my console. Let me kill this server. Let me kill this server. Terminate. Let me just create 2 servers. Launch. SSH server. I'll call it one SSH server and SSH client. Amazon Linux 2. Key pair is Frankie, network, VPC, Frank VPC. So select existing security group, Frank SG. That's it. Number of instances, 2. All right, great. Launch. Guys, watch you. View. All right. So let me call one client and the other server. So bam, 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 bam. So what I want to achieve is, yeah, I have a client machine, client VM, and server VM. Let me just give it SSH server, SSH clients. All right. Which we have here, SSH server, SSH clients. They are both running. All right. Now, so they already have this setup, private key and their public key. So there's no need for me to go through that route again because I've explained it here. But now I want to do something separate. I want to do something different. All right. I want such that on this SSH clients, a user, the EC2 user, all right, should be able to SSH into from the SSH clients into SSH server. I come again. I want it such that an EC2 user on the SSH client should be able to SSH into what? SSH server. All right. For that to happen, okay, before I go there, let me talk about something. Before I come over here, let me talk about something. I'll come back to this part. SSH authentication. Now, there are two kinds of authentication in SSH. We have password-based authentication and key-based authentication. We have password-based authentication and key-based authentication. Password-based authentication is with the use of password. Password-based authentication, let me abbreviate it to PBA. This method is with the use of password to authenticate to a remote server. Right? To authenticate to a remote what? Server. Now, the key base one second, guys. 1 second, please. Okay, let them come. 1 second, guys, please. So, key-based authentication. This method is with the use of private and public keys to authenticate to a what? Remote server. Now, in production, we make it necessary it is necessary to disable password-based authentication and stick to only key-based authentication. You can never see where they are using what? Password-based authentication, all right, to authenticate to a remote server via SSH. The reason is simple. It's because a Linux machine can easily be brute forced. You can easily brute force a Linux server. The reason is a Linux server can easily be brute force. All right, can brute force a Linux server to take control over it. So for you to avoid brute force attack, for you to avoid a brute force attack, it is recommended that you disable password-based authentication and enable key-based authentication all through. Now, this is what I wanted us to explain. So I'm going to start with a password-based authentication. All right. I will show us, see how it is, but we won't be going with what a password-based authentication. All right. One sec, guys. So we won't be going with password-based authentication, but I just need to show us. So this is what I will do. All right, let me bring these guys down. I think let me bring them down. All right, now back to this explanation. This guy wants to SSH to this guy. There's a user here. Let's say there's a user called Tom. Tom user. All right. Then Tom has a password. The EC2 user has a password. Okay, great. Now, let me switch to my local network, please, so that once I connect to this EC2 instance, they won't terminate. They won't time out. They won't time out. They won't time out. All right. All right. So now I want to connect to these two guys. I want to connect to these two guys. Let me start with the clients. Connect SSH clients, copy, come to my terminal. This guy should have gone off. This is my SSH clients. Great. So let me change the host name. Let me change the host name. Let me change the host name of this machine. To change the host name of this machine, I'll go to sudo this, then I'll go to vim etc host. We did this sometimes. Host name. All right. So this is the default host name. So I'm going to delete this guy. I'll say SSH clients, escape, save, and quit. All right. So it won't show now until I reboot the machine. All right. So for that, let me reboot the machine on from here. Or I could just, okay. Let me reboot the machine instances, SSH clients, instance, reboot. So I'll connect to my SSH server, connect, copy, come to my terminal, over here, paste. Yes. All right, sudo -i, then vim etc hosts name. I'm changing the host name. All right, delete that and SSH, call it SSH server. Great. We are good. Now, reboot. Reboot. It's rebooting. I don't know if I use this method though. All right. So now let's connect back to the SSH client. I think it should be back up now. Connect, copy. All right, it's still not up. Still not up. All right, it's up now. Now you can see the host name has changed to what? SSH clients. So we'll do similar thing with the server. The server is back up. SSH server. Great. Let me bring it like this. So that's yes, clients, and here is server. Clients, server. Now, from our illustration, there's a U2 EC2 user. Let me change this user. Let me call it let me call it Jerry. Let me call it Toby. Toby, that's okay. Let's say Toby. All right. Toby is on SSH clients, which is this. Now I create a user, sudo user add Toby, sudo pass wd for Toby is 1212. I've created the user Toby. So if I check my home directory, I should have what? The Toby user. Now on the server, I need to create a user called what? Tom. Sudo user add Tom. Pass sudo pass wd Tom 1212. Great. Now look, the Toby user wants to authenticate to the Tom user via SSH. This is what's going to happen. All right. Now, I will say, all right. So I'm going to switch user Toby. Toby wants to SSH from client machine to Tom user on a server machine. So I'll say SSH Tom at the IP address of the SSH server. Now, there's a command called ifconfig. Ifconfig is a utility that's used to display the IP tables. All right. So I want to check the IP of this server. You can see the interface is ETH0. There's a loopback interface, LO, which is localhost 127.0.0.1. All right. So I'm only concerned about this interface, which is the ETH0, which is my IP address is what? 10.0.2.9. All right. So I'll copy this guy, come to my base machine. All right. Not my base machine, come to the client machine, and I'll paste this guy. See, this Tom user is a user on the server, on the SSH server. And this IP is a private IP of the SSH server. I am using private IP because both the SSH client and the SSH server, they are on the same subnet. They are sharing the same subnet. So authentication will go. So if I try to even ping that guy, all right. So you can't ping a private IP directly, not until ICMP is enabled on your firewall, which is your security group. Because by default, AWS disables pinging. You can't ping a private IP. Now let's go there and check. Let's click on SSH clients, come to security group. Here's the security group, right? Open security group. And I'm going to add the rule. See, so far, the pinging is not going. It's not going. But the moment I enable that rule, edit inbound rules, add the rule for ICMP. You can see all ICMP protocol. All right. Custom is anywhere, save. The moment I save this, I check this guy, you see that pinging is now going through. Connectivity is now what? Going through. All right. So take note, guys. By default, on the cloud provider disables pinging because of security reasons. All right. You can't ping a private IP address. But for the sake of this class, I just want to keep it on. All right. Just to show something. Now, I've tested the pinging is going through. Now, I want to SSH to that Tom user. Let me show the syntax first. The syntax is this. Here's the syntax. Is SSH space username at destination IP address. This is the syntax. Now, example, SSH space Tom at the private IP. So if I try to hit enter, now look at now, I'm trying to copy my fingerprints into the destination machine. This was happening now. The authenticity of this guy can't be established. ECDSA key fingerprint is this. Easy fingerprint is this. Are you sure you want to continue connecting? It's telling me that because it doesn't know this remote machine. That's the behavior of SSH. So it's a kind of a warning. All right. Telling that I don't know this machine. I don't know the fingerprint. Are you still sure you want to go ahead to connect? I say yes. I'll type yes. Now, it's going to throw up an error. Permission denied. Because what? By default, on a cloud Linux machine, password-based authentication is disabled. Password-based authentication is disabled. So I need to enable it, right? So what I will do, I'll go on the server side, all right? Sudo. Now, there's an SSH configuration file. The file is on /etc/ssh/ssh_config. Thank you. Sorry, SSHD_config. That is the configuration file for SSH. I'm going to open this file. This is on the server side though. Now, like we said, by default, SSH runs on what? Port 22. Let's keep scrolling. Let's go to where, so these are different configuration. Now, root by default is not allowed to log in via SSH. So it's disabled. Permit root login is disabled by default. All right. Permit root login is disabled by default. Okay. So if you want to enable it, you remove this comment, but it's not advisable. It's not recommended. All right. Now login grace time. Login grace time is the number of time to authenticate to the destination machine. Now maximum session by default is 10. That's maximum open SSH session. Now we have public key authentication. Here's the part if you want to use public key-based authentication. Okay, let's look for password. Let's look for password. Now see you. Password authentication by default it is set to no. All right. So I want to change it to yes. I'll come here, edit. I'll say what? Yes. I will escape. I will save and quit. All right. I'm going to restart the service. System CTL restart SSHD. That's the daemon for SSH. Then I will come back to my client machine. Let me try to authenticate again. I'll recall the command SSH tom at that IP. I'll hit enter. Now you can see now it's now going through somehow. It's now asking for what? Tom's password. I'll say 12. Tom password is 12. I'll press enter. You can see I have comfortably SSH into what? This server. Amazon Linux 2, a new version, blah, blah. I have SSH from the client machine. I have SSH from the client machine to what? To the server machine. You can see. You can see now. This Tom server. All right. Now, I cannot escalate my privilege. Escalating my privilege in the sense that I do not have a root access, a root right, a sudo right. So I can only remain within the user Tom. Within the user Tom. All right. So let me exit. To come out of that remote session, I'm on the remote machine now. All right. I can touch some files. Touch let me see, touch who? Touch Toby connects.txt. All right. I just created a file, touch Toby connects. Now, if I exit now, you can see now, log out. Connection to this host is now closed. Connection to that host is now what? Closed. If I go to this server, here's the server, right? If I check the home of Tom, okay, this guy can't check. Doesn't have the right. This easy to use, I cannot check. So I'll say sudo Tom ls-l. I will see that this was a file that got created from this remote connection. Great. Now, remember what we did on the server end. We had to go into this file, SSHD _config, to change the password authentication from no to yes, so that we can authenticate via what? Password. All right. So this is what I just wanted to show us. But guys, this is very risky from a security point of view. So I need to change it back. In production, never ever enable password-based authentication. All right. Never, sorry, systemctl restart SSHD. All right. So if I try to authenticate now back, I should have a permission denied, because what? Password-based authentication has been what? Disabled. Before we go into Keybase, is there any query? Is there any query where we need to clear out? Is there any query where we need to clear some doubts? No query. Let's move on to what? Keybase authentication. Now, in Keybase authentication, I'm going to generate key pairs. This was password base, PBA. Password base. Let me copy everything here. Now, for Keybase authentication, all right, remove this line. Toby, guys, watch you. Toby is going to generate a key pair. The Toby user is going to generate a key pair. One key is a private key, and the other key is a public key. A private key and a public key. Guys, watch you. After generating this key pair, Toby is going to share this public key with the SSH server. This SSH key is going to be shared with what? The SSH server. Then Toby should be able to authenticate from his client machine towards the server machine. Why? Because Toby has his fingerprints. Toby has already created a trust. Toby has created a trust with what? This SSH server through his public key. That's the flow, guys. Toby has created a trust. Toby has created a trust. Toby has created a trust with the SSH server through what? Is what? Public key. Then Toby will be able to what? SSH into what? Into the server machine. Let's go there, guys. I want to start. Toby is going to generate a key pair. To generate a key pair, this is Toby, right? This is Toby. There's a command called SSH-key generate. Toby is going to use this key, SSH key generate, to generate a key pair. All right. I want to press enter. Now, when you're trying to generate a key pair, what SSH would do is SSH try to create, or what the Linux file system will do. The Linux file system will try to create a .ssh folder. All right. See now. See, generating public, private, RSA key pair. Now, this is by default the default location where SSH is going to store the key pairs, the private key and the public key. It's saying that enter the file in which to save the key. Most of the time, which is 100% of the time, we always take this default location, leave it as it is. I don't want to change anything. Just press enter on your keyboard. Take what you see, enter. It's always by default. Now it's now asking for what? A passphrase. To add more layer of security, you can put a passphrase, all right? But there are situations when we shall come to GitHub, right? Because since 2021, GitHub disabled the use of password to authenticate to your repository. They changed everything towards key-based authentication. So we are going to see the application of SSH with GitHub when we get towards GitHub by next week, by God's grace. All right. So when you're dealing with that, most of the time, if you like to put passphrase, if you don't want, but let's just put a passphrase. All right. I'm going to type 1212, enter. Enter the passphrase 12, enter. It's saying that saving key to this failed. Passphrase is too short. Minimum 5 characters. Let me recall again. Let me regenerate. That's okay. Enter passphrase 12345. 12345. It has accepted. It has what? Accepted. Now, if I go to that location, check now. Change directory.ssh. Now I have what? I have ID_RSA as my private key. ID underscore RSA dot pub as my public key. Let's see each of these one after the other. So I'll check the content of the ID first, just RSA. This is my private key. You can see end of RSA private key. This is my private key. Now let's check the content of my what public key. IDRSA.pub. This is my public key. You can see at the end we have Toby at SSH clients. Right? This is the format of a public key, guys. This is the format of a public key. So now I have generated what? A key pair. Toby has generated a key pair. Now Toby wants to share this public key with what? The SSH server to create a trust. To create a trust. So I'll come here. I'll just open the contents of this file. id.pub. Simple. Open the contents. All right. Then I'll just highlight everything. Right click. Copy. I'll go to the server. On the server side, which is Tom Abi, I will switch user to Tom. I have switched to Tom. Check if Tom has that file. That's .ssh. Tom does not have the .ssh directory. So this is what Tom would do. Tom is going to make a directory, mkdir, called .ssh. Is created. All right. Is created .ssh. Now, Tom is going to go into that .ssh and create a file called authorized keys. Authorized keys. So Tom will create a file, vim authorized underscore keys. Well, let me check the right spelling so that I don't make a mistake. Let me check on my base machine. Cats. All right. All right, let me go back here. Authorized keys. Well, let me open this file. Sudo vim etc sshd. All right. Now, sorry. This guy is not part of. He's not a sudo user. All right. Sudo vim etc sshd. All right. Now there's a file called authorized file. Yes, now. The default is to check both this guy and this guy, but this is overwritten to so installation will only check this guy. Now, this is the authorized key file. The authorized key file, you can always change it from here. So there is a default name. It's a default name by default. This is the name it bears, authorized underscore keys. This is where you copy all the keys, all the public keys to. Any machine that you want to have access to your own machine, this is this file that you copy their public key into. All right. So here is the authorized key file. The authorized key file is under this location .ssh authorized key file. So this is a file we need to create. Copy, go out. Now let me switch back towards the Tom user. Now Tom created a directory called what? .ssh. Now Tom need to create a file called authorized underscore keys. Now in this file, I'm going to copy Toby public key. I will paste it. I've copied Toby public key. What I'm trying to establish is what? Trust. Toby is trying to establish trust to what? To this server. So Toby is going to copy his public key into this server, which I have done. Then I will escape. I will save and quit. Fine. Now, on this Toby machine, Toby now wants to connect, wants to authenticate with what? The SSH server. Just look at what will happen. Toby will say SSH Tom at, what was that IP address again? History. Okay. SSH Tom at 10.0.2.9. I'll hit enter. Permission denied. Let me restart the service here. I'll say sudo, okay. Exit. Sudo system ctl restart SSHD. Let me try it one more time. Permission denied. Now let's look at for some settings. Oh, public key authentication is disabled. Let's check. Sudo vim etc SSHD. Now let's check for public key authentication. Saw it somewhere. Let me go down. You see, let me know. I saw it somewhere. No, I saw it somewhere. Let's go back to the top. I saw it somewhere. Public key. Here it is. Here it is. Public key by default is disabled as well. So I have to enable it. I have to explicitly enable it. Public key authentication. Yes. Escape. Save and quit. Now, restart that service. Restarted. Come back to this my machine now. Let's authenticate now. Enter. Wow. Bam, 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 bam. You know, Tom user. Let's go back. Let's see why we can't come in. Public authorization. Authorize. Let's see. To disable password authentication. No. I mean, password authentication. Challenge response. Challenge response authentication. Wait to challenge key exchange, API key exchange. Set this to yes to enable PAM authentication. Use PAM. Allow agents. Permits TTY, which we have. They come use privilege separation. They come. Let's see. All right, let's go back to the top. Authorize keys. Let's go back to the top. Let's go. Yeah, it's somewhere here. This challenge response authentication. Let me say it. I don't know why I did this thing. It's supposed to just go now. It's supposed to just go. All right, let me say yes. I changed that guy to yes. WQ. Challenge response. Sudo restarts. Let me try again. Okay. 1, 2. Perfect. Let me go out. Now, on a normal machine, I won't be having those kind of this error. I'm not supposed to enable this challenge response. All right. But change to no to disable key passwords. Change to no. Okay, to disable key password, change to no. All right. So now for you to use your public key, well, let's go to the public key part. Let me disable this part yet. So by default, it is disabled now. All right. Now let me restart. Restarted. Come back here. Let's try to authenticate again. Okay. All right. So what I'm supposed to change was just the challenge key response and not even this public key authentication. All right, take note, guys. So change your challenge response authentication to yes. All right, to use a key-based authentication. All right, key-based. All right, great. 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 But wait, there's something. It's supposed to show me. It's not supposed to show me password. It's not supposed to show me password. It's supposed to show me enter passphrase. It's supposed to show me enter passphrase. All right. Enter passphrase. This is this guy password. I'm not supposed to use password. I'm using password now. I'm using password, guys. What I'm using is password. The passphrase is 1, 2, 3, 4, 5. So which is not coming. So let's go back there. Power authentication, no. This thing is supposed to not show me like this. Authorized key. Public key authentication. Put it to yes. Put it to yes. Then this challenge response. Challenge response. All right. I don't know why he's doing like this, but I'll show something. I'll show something. Escape, save and quit. Restarts. It's not supposed to show me 1, 2, 3, 4, 5. It's picking the password. All right. It's picking password. It's not supposed to be like this. So this is between two cloud machines. It's picking the password. No. The setting is I come, guys. Apologies, please. Kerberos, not Kerberos. Option. API acceptance check. Clean up credentials. Well, let me try something. Let me say no of this. Restart the service. Come over here. No. It's still showing me that. Right. Okay, let me just show us what I wanted to show us. What I want you to see. All right. What I want you to see. Not this password thing. Let me copy my own base machine key pair, public key, into this server. All right, into the what? Into this server. Let me come over here. So this is my local machine, right? So I'm going to cat dot ssh id dot pub. So here is my own. This is my local machine on my Mac. Public key. Copy. Now I'll go to what? I'll go to this SSH server. All right. Switch user to Tom. All right. Change directory to SSH. Then I'll edit this file, authorized keys. Inside this file, I'll paste another public IP. Escape, save, and quit. So I'll exit, then I'll restart the service. Great. So now I'll be using what the public IP because I'm connecting from the outside. I'm connecting externally into what? Into a remote machine. So I'll use the public IP of the SSH server. SSH server. Public IP of SSH server is this. Copy. I'll come over here. I'll now say SSH Tom at the public IP. All right. I'll hit enter. Seal. Normal process. Fingerprint. Yes. Enter. Tom password. Why? Why is it asking of Tom password? I have typed Tom password. No. Something is wrong somewhere, guys. Something is wrong somewhere. There's a setting I'm not doing properly. There's a setting I'm not doing properly. There's a setting. Password authentication. Password authentication. No now. It's no. Remote host. Host-based authentication. Authorized principals files. Authorized keys. Public key authentication. Public key. Yes. Login. Ciphers and keying. Key limits defaults. Host key. Oh, why this thing? Why I do like this? What did I do? All right, guys. All right. Let's I'll get that parameter because it's not supposed to ask for password. It's not supposed to ask for password. Well, let me look up something. Enter. Key-based authentication in Linux. Let me look up something. Let me check something. Let me check something briefly. All right. Okay. Copy an SSH key to a remote server. Which you've done this part. Authorized keys. Okay. Okay, which you've done. I've done this part. Okay. It is SSH underscore D config. Password authentication is no. So yes, and the only thing now, and the only thing, wait, this challenge response. Now the only thing, restart. So now it will give me permission denied. All right, great. Public key, GASP. All right, API. All right, I think I'm getting close now. Now let's go down. Let's do now. Yoko. Authentication to no. Authentication to no. Restart. Try it now. No. Permission denied. Permission denied. Public key. Enable key for your key exchange. API key exchange to yes. 1 second, guys. Restart. All right, guys. It's something I will check. It's something I will check. It's something I will check. Then I'll revert. Let's not no, I will check it. I will check it. It's something that I will check and revert. Okay. I'll check and revert. Now, what we normally do in production, as we just mentioned, you want to give access to Toby wait, guys. Wait. Let me do something differently. I want to do something differently. All right. So on this machine, let me create a user called Toby. User add Toby. All right. That's Toby. Now sudo switch to Toby. That's Toby, right? Now make a directory .ssh. Go into that directory. Create a file called authorized underscore keys. Authorized underscore keys. Now copy this Toby on this other machine. All right. Public key. Copy is public key. Copy. Come over here and paste it. Escape. Save and quit. All right. Great. Now exit. Now sudo restart. Now let's Toby try to authenticate with Toby. Come back here. Let me check. Let me change what I change. Password authentication, no. Challenge response. No, it's asking for password. All right, guys, I will check out the appropriate parameter and I will relate that to us. But in reality, what we normally do is Toby wants to have access towards this SSH server. So Toby is going to generate a key pair. It's going to generate a key pair. It's going to generate a key pair. Wait 1 second, guys. Let me try something. That same password, let me copy it inside of this guy, the EC2 user. All right, vim authorized keys. Paste. Okay. Great. restart the service. Let's come in with the EC2 user. EC2-user. Hello, guys. This is what I wanted to show us. This is what we should see instead. This is what we should see instead. Okay. Enter passphrase for key. The Toby. Look at now. I don't know why. I don't know, but it's supposed to. I don't know why it happened like this. Is it because those users are not pseudo users? I will try something, guys. I will try to add those guys to sudoers group, and let's see what happens. All right. Now, I'm going to type the passphrase 1, 2, 3, 4, 5. I've logged on into what? This server with this user, the EC2 user. All right. I've logged on to that server. Let me exit. Look at now. So I shared Toby's key with Toby's public key. I shared with this server. All right. I share it on the EC2 user home. Now, on the EC2, there's a .ssh file directory. Sorry. Now, under there, I have an authorized key file. So it is inside of this authorized key file that I have shared, that I have mentioned Toby's public key. All right. Toby public key. So what we need to do is just simple. All those things I was doing wasn't necessary. Just to go back to this guy, all this thing was not necessary. I think just this part. Password authentication, no. Key-based authentication, yes. These were the parts. All right. These other guys, they are something else. These guys are something else. All right. They are something else. Okay. So, and boom, we are in. So this is what you should see, and not that password thing. You see that passphrase 1, 2, 3, 4, 5. That is a password, and automatically I'm logged on onto what? The SSH server. You can see now. So Toby now has created a trust with what? The SSH server, because of his what? Public key that was shared with the SSH server. So going forward, Toby can comfortably authenticate without errors, guys. All right, that errors. Now, before I come to the aspect of copying files between SSH to Linux to Linux machine, okay, before I come to, all right, let me should I? No, let me not go that aspect. I'll come there later. Toby wants to copy some files. See, Toby has created a trust between himself and the SSH server. Now, Toby needs to copy some files into this machine. This is what Toby will do. Let's go somewhere. This is Toby home, right? Now, Toby wants to touch some files. Let's call it finance toby.txt. Touch audit toby.txt. Now, let me create some content into this file. Let me say echo. This is for financial transactions. All right. I'll echo it into finance Toby. It's now there. Echo. This is for auditing transactions. All right. I'll echo it into what? Audits. So if I check financial, I have content. If I check audit, I have content. So now I want to copy these files from the SSH client towards the server. So this is what I will do. I will now say SCP. SCP is a utility for copying files between Unix to Unix machine. SCP. This is a utility used for copying files between a Linux to Linux machine. All right. So use what? SCP. So I want to copy some files. Now I'll come over here. I'll say SCP. The file name, right? The file name is finance. I want to copy finance to where? To EC2-user at 10. What's that IP? 0.2.9. All right. So if I hit enter, I don't think that's gone. It didn't go. Let's check. It didn't go because this should be the home. PWD. It didn't go. So you have to specify the path. This is how you do it. SCP column / home / EC2 user. So I want to copy this file. I want to copy, where's that guy now? Where's my cursor? I want to copy this file into this server at this location. Into this server at this what location. So if I hit enter, it will ask for my passphrase. 1, 2, 3, 4, 5. Enter. Determine that this file was copied. Let's check. I'll come here. I'll do LL. I have finance Toby. Let me go back. Let me copy the auditing file as well. SCP audit. EC2-user at 10.0.2.9 column / home EC2. Copy. 1, 2, 3, 4, 5. Copy. Let's check. LL. I have audit. Now, what if in a situation I want to collect a file? I want to collect a file from a remote machine into my base machine. So it means that there's a file somewhere on the SSH server, which I need to collect, all right, into what? Into the client machine. Let's see how to do that. Now, this is the what? The SSH server. I have a file called cats. Let me call it markets leads.csv. This is the email addresses of potential clients. This is their details. Control D. Cards, market leads. All right. Now I need to copy this file from this server into what? The client machine. This is what I will do. I'll say SCP. I will reverse what I did. Now this is in the forward when you're copying. Now I want to reverse it. So what I will reverse, I'll say SCP, copy from this guy. Copy and paste. Now what's the file name? The file name is market leads, right? Market leads.csv. Copy it. Paste. I need this file into my base, my current directory. So I'll use a dot. So this is what I'm doing. I'm doing using SCP. I am going into this location on the remote machine. On this location, I need this file. I want this file to be copied into my what? Current directory on my own machine. I'll hit enter. 1, 2, 3, 4, 5. Copy. Now, if I check my client machine now, I have what? market leads. I have market leads. All right. I have market leads. So check the content of market leads. The same thing. This is how you use SCP to copy files back and forth. To copy files back and forth. Now, let me go back to what didn't work. I copied my public key to Tom directory. Even when I also created a Toby directory. But it didn't work. Whoa, wait, Mike, I check something. Wait, let me check the permission on this. Is easy to write. Let's check the permission on this file. EC2 user authorized key. Okay, the user read write. Okay. Let me try out something, guys. Sudo Tom. Change to SSH. So change this permission ch mode. Ch mode. Let me give it that would be 600. That would be 600 unauthorized keys. Now let's check. So this is what I get, right? This is what I get. Okay. Now let me try to connect with Tom instead of. So let's say SSH with Tom instead. Tom. Let me see. Nobium. That's not a problem. All right. So let me try to add Tom as a sudo user. Now, next topic. So sudo enables you to assume root privileges. The sudo utility is used to grant super user privileges to ordinary users. That's what sudo does. All right. To ordinary user. So how do we grant sudo rights to ordinary user? Let's go there. Now there's a file. There's a file called etc sudoers. There's a file called etc sudoers. Let's open this file and see what's inside. Let's scroll to the ground. Now let's check. Sudoers allows particular users to run various commands as the root user without needing root password. All right. So let's go down and see something. Let's go. Let's see. Let's go down. Let's go down. Let's go down. Let's go. It's at the bottom. Now, here we are. See you. Now, this section allows the root to run any command. The username, then these are permissions. All is equal to all equals to all. This section allows people in the group will to run all commands. Now, all right, meaning that any user who is a member of this group will automatically be able to perform root writes. All right. So let's do something. Let me add Tom user to the wheel group. Let me add Tom user to the wheel group. So this is what I will do. Let's check first. Cat etc group grep wheel. So you can see that the EC2 user is a member of the wheel group. So it means that the EC2 user can perform sudo as writes with what? The command sudo. Let's add Tom to that group. So I will say sudo user mode dash a capital G, the wheel group, and what? Tom. So I'm adding Tom as a secondary member to the group wheel. Enter. Now let's check the file again. You can see Tom is now a member of this group wheel. So it means that Tom can perform sudo's command now. Let's check. So if I do something, sudo switch to Tom. I now say sudo system ctl restarts sshd. So ordinarily, an ordinary user cannot run this command. It is only a root user. Now, Tom has a password. I'll say 12. It was successful. Now, assuming that I remove Tom from that group. So if I say group mems, sudo group mems no dey group member no dey let me do something. I can go into the file. Let me exit. Group mems no dey now see, I want to show us something. There's a command group mems, it's not here, but I want it. So this is what I will do. I'm going to look for the package that controls that command group mem. Group mem is a command, but I need to install a package to make the command group mem available. That command is not there. All right. So for me to determine which package controls that command, this is what I'll do. I'll say yum what provides. What is it? It's like one word. What provides yum, what provides group mems. Let's check. Let's check. Why is it taking time? Let's check. What provides? Come over now. Why is he hanging, guys? Okay. Utilities for managing accounts and shadow password files. Repo is installed. So why can't I have it? Wait, sudo oh, okay. It's not available to that guy. It's not available to that EC2 user. So it's already installed. So this is a package that controls group mems, guys. This is how you know which package controls a binary. All right. Which package controls a binary? So this command you're seeing is a binary. All right. So you use what? Yum what provides, then the binary name to tell you the package name you need to install. All right. Now, for instance, now if I say yum what provides telnet. So You tell me the package that I need to install. This is the package that I need to install to use what? This binary telnet. Take note, guys. All right. So now I need to delete that member. So I'll say group mems dash d. All right. Delete who? Delete Tom from group will. Now let's check now. Cat etc group grep what will. So Tom is no longer a member of the group will. Now if I switch to Tom user, now if I try to do that command that I did, sudo systemctl restart sshd, you tell me that Tom is not in the sudoers file. This incident will be reported because now Tom is not a member. It doesn't have that sudoers rights. So let's put it back. So group mems, just recall it. Just recall it. Okay. Exit. Just recall that command I did. Where's that command? Yeah. So add, just say A. Tom is now a member. Now let's check. Check. Tom is now a member. So if I switch to Tom now, and Tom wants to run that command that he did, very simple. Tom has been able to run it because Tom is now a member of a sudo. He has a right. Now, let's go back to that file again. Sudoers. I added Tom as a member to this group. Now, what if I want to add the user directly? I'll use this method. As either I use this method or I use this section. So this is what I will do. I'll just type the username. I'll type the username. So I'll say this. I'll copy and paste. So if you're dealing with group, use the percentage the group name. As you see here, users don't have percentage. All right. So the username will be what? Toby. Great. All right. Escape, save and quit. So Toby now. Now Toby now is now part of the sudoers group. Now let's check now. Let's check. Switch user to Toby. All right. Now Toby wants to use sudo command. Sudo systemctl restart sshd. It's asking for password. 1, 2. Now I don't want sudo to keep asking me for password. Let me do something. I will exit. I will go back to that file. I want it such that Toby should not be asked for password at the first time he uses sudo. So I'll add this flag, no password for all commands. So I'll come here. I'll say space, no pass wd all. I'm supposed to show like this. All right, okay, it's different. This is okay, this is yeah, this is all right. So this is syntax. Will all, no password. This is how it should be. All right. Escape, save and quit. Escape, save and quit. Now switch user to Toby. Now Toby wants to use this command. Toby should not be asked for a password. Simple. There's no password. Before Toby was asked of a password, which Toby does not have a password. Now Toby is no longer asked for a password. So this is how you give sudoers rights. Okay. Now this is what I wanted us to check. I want to check because now I've added Tom as a sudoer. Let me see if this command will fly. this thing we were trying to achieve. Okay, let's see that now. Where was I? All right, sudo switch user to Toby. Now switch use SSH Tom at 10.0.2.9. Let's see. It's the same thing, guys. It's the same thing. It's the same thing. So it's better you copy, it's better you share that key. Share that key with, share your public key, copy your public key to this user own SSH. All right, this guy has a SSH. Change.ssh, the authorized keys. So you have to save the authorized keys. You have to save your public key under the authorized key of the EC2 user. I don't know why I'm having this challenge. All right. On Ubuntu, I didn't have this challenge. On Ubuntu, I didn't have it. It just went straight. You can try yours when you're practicing. Try yours with Ubuntu, all right, and see the difference. You're not supposed to have this challenge. I think that's so far about SSH, right? SSH. When we get to GitHub, we shall see how we shall also see the application of what SSH, where we will have to copy our generated key pair, especially the public key, onto GitHub. We're going to share our public key with GitHub to create a trust with what? With GitHub. No, it doesn't have, it's the same thing. It's the same thing. You mean WSL now, Onoche? Yes, now it's the same thing. Yes, it's the same thing. Now, what console are you using? What console? What do you mean, Dotun? The terminal. Unmute now. Unmute and talk. Unmute.
Yeah, I'm talking about the terminal.
Yes, the terminal is I created two machines now. I created two machines. I'm demonstrating this guy with two machines, client and server. All right. Your own, if you want to use your Windows machine, there's SSH. You can if you want to use PowerShell, there's SSH on PowerShell. This command will work. SSH keygen, it will work. Right? I think I need to share this guy with you guys so that you just read along how to set up key-based authentication. So just read along. Just read along. All right. Any other query, guys, before we call it a day? Any other query? Okay, so let's just do a brief recap. Where do we start from? Remote management. There is an SSH. We were told all of these. SSH runs on port 22, and SSH is a TCP protocol. All right. And yeah, for AWS, all right, once you create an AWS instance, what AWS will do for you is to generate two keys, all right, your key pair. So in that your key pair, it's going to download for you the private key, while it's going to upload for you the public key onto the EC2 instance, which we saw. Then you use the private key to authenticate to the EC2 instance. Now, if we need to set up SSH manually, all right, okay, before that part, there's two types of authentication, password-based and key-based. So we saw the password-based with the use of passwords. Then we saw the key-based with the use of public and private keys. Now, this was what? Password-based authentication. Now, for the key-based authentication, Toby had to what? Generate a key pair. All right? Generate a key pair where one key is private key while the other is public key. Toby has the private key while the public key is being shared with the server, all right, to create a what? A trust between Toby and the server. So once this trust has been created, has been established, Toby can automatically authenticate to what? To the server. We also saw what? SCP. SCP means secure copy. This is a utility for copying files between the Linux to Linux machine. We also saw what? Sudo. Sudo is used to grant super user privileges to ordinary users. So we saw sudos in different angles as a group and as an individual user. So that is it, guys. Okay. Because of time, I won't be able to cover AWS CLI. I'll leave it when we meet on Friday. Before we talk about Git, please remind me, guys, I am going to touch AWS CLI. Let me see if I have that guy here. I think I don't have it. Just the Linux. It's just the Linux. I don't have Git here. All right. So I'm going to talk about AWS CLI. Aside that, guys, any other question? All right. I'd love to see you guys on Friday. Thank you for your time. Thank you, and have a good week ahead. See you on Friday.